Hi guys, this video will cover additional practice with horizontal and vertical components of velocity, the homework that is due tomorrow, which is Wednesday the 20th. So what we're going to do is we're going to go through question number 1, and hopefully this will give you a good base for doing the other 2 questions on your own. So number 1 says a water balloon is launched with an initial speed of 40 meters per second to the right at an angle of 60 degrees from the horizontal. So our first task is drawing a picture. And what does this mean, 60 degrees from the horizontal to the right? Well, it means is the horizontal is typically a straight line, left to right. And if the water balloon is being launched, typically what that would mean is it's being launched from the ground, because it would be kind of difficult to launch a water balloon from the air, so we can just assume it's from the ground. And it's going to the right at an angle of 60 degrees from the horizontal. So that means it's going up this way. So this right here represents the path of the water balloon. It's being launched at an angle of 60 degrees. And we have to figure out the horizontal and the vertical components of velocity. So let me just draw this. This is our vertical component. And the vertical component would be going up because the water balloon is going up, and the horizontal component would be going to the right because the water balloon is also going to the right. So our picture looks something like this, and we can also write in the initial speed of 40 meters per second as the hypotenuse of the triangle, because that 40 meters per second is the path. That is the path of the water balloon. Like eventually it would probably do something like this, go up, and then it would eventually come down because gravity of course would take it down. But we're only looking at this first initial velocity, so that's why we can draw the triangle like that. So we need to calculate the initial horizontal component of velocity. So what is the horizontal component? Well, horizontal means left to right, so that means this leg of the triangle, and we'll call this v sub x. Once again, v stands for velocity, and the x just means it's going in the x direction. We're looking for the component in the x direction. So how do we solve for v sub x? Well, we can use trigonometry. And this is what's so interesting about this outcome. We discovered that trigonometry, it doesn't just work for side lengths, it works for velocities as well. We can use it with velocity and speed. So if we're calculating v sub x, and we know this angle 60 degrees, and we know the hypotenuse of the triangle 40 meters per second, we can use cosine, because we're looking for adjacent, and we have the hypotenuse to solve for v sub x. So what would that look like? Well, we can set this up as the cosine of 60 degrees is equal to adjacent, which is v sub x, over 40 meters per second. And if you solve that, well, I'll let you guys solve that because I don't have a calculator handy. So you're going to get something, it's going to be less than 40 because 40 is the hypotenuse, so these other 2 legs have to be less. How would we solve for part C, the initial vertical component? Well, vertical means up and down, so we're looking for the speed in this, or the velocity in this direction. So we're looking for v sub y. What could we use? Well, we're looking for opposite. We have the hypotenuse, so that is sine, right? So the sine of 60 degrees is equal to v sub y over 40, and I'll let you guys figure out what v sub y is equal to. Once again, it's going to be less than 40, because we know that the hypotenuse has to be the greatest, the longest length of the triangle. Now let's consider real quick the signs. V sub x is going to the right. The right typically means the positive direction. So whatever number you get for v sub x, that's probably going to be positive. You're going to keep that number positive. V sub y is going in the up direction. Up is typically the positive direction. So whatever you get for v sub y, you're going to want to make that positive. Okay? Good luck. Let me know if you have any questions.